Alright, so to finish up this section about solving quadratic inequalities, 5.2, kind of forgot what it was yet, or for a second. Let's go ahead and do these. So when you have 4x quantity squared is less than or equal to 32. So the idea is always undoing the operations in the correct order. The outermost operation is the square, so we're going to take the square root. And when I take the square root, I'm going to remember that those two simplify each other out, and I'm left with 4x. But then you put the positive square root here, repeat the symbol on the other side, and put the negative square root there. Okay? Hopefully you remember that the square root of 32 can be simplified. 32 can be written as 16 times 2, and the square root of 16 is 4. So that's 4 root 2. So I've got negative 4 root 2 is less than or equal to 4x, which is less than or equal to positive 4 root 2. And then I'm trying to solve for x, so I'm going to divide by 4 each thing. So I'm left with negative square root of 2 is less than or equal to x, which is less than or equal to the square root of 2. So this quadratic is less than 32 when x is less than the square root of 2, less than or equal to the square root of 2, and greater than or equal to the negative square root of 2. And this is a statement that makes sense. X is less than or equal to the positive square root of 2, but greater than or equal to the negative square root of 2. So that is my final answer. Okay, so the next problem is where we get into a little bit more of a different scenario. So when you've got x squared minus 7x plus 10 is greater than 0, it's not as easy as just like, let's subtract the 10 and solve for x. You can't really do that. What you can do is recognize that this quadratic, well, see what we can do with it. What I notice is that 10, its factors are 2 and 5 and 1 and 10, and 2 and 5 add up to 7. So if I think about it, I could factor this. The factors of 10 that add up to negative 7 are negative 2 and negative 5. So I could think of this parabola as x minus 2 times x minus 5, and then sketch it. So here's what I know. I've got a parabola that opens up because it's a positive quadratic. I know that it equals 0 at 2 and 5. Its roots are 2 and 5, so 2 and 5. And if I've got a parabola that opens up and has roots right there, then I know that it basically looks like this. So the question is, when is this quadratic greater than 0? So to be greater than 0 means to be positive. And this quadratic is positive here, and it's positive there. So I can just see my answer and say my answer is from negative infinity until 2, and then from 5 until positive infinity. So just by looking at it, I can do it that way. Okay? And that was because I could factor it. So this next one, x squared plus 7x minus 8. So given what we just did, I'm going to try and do the same thing. Are there factors of negative 8 that add up to positive 7? And so we've got 1 and 8, which do have a difference of 7. And if I make 1 negative, then I get positive 7 when I add and negative 8 when I multiply. So this is x minus 1 and x plus 8. Now I'm just going to set this equal to 0 for a second. I know it equals 0 when x equals 1 and negative 8. But the real question is, when is it less than or equal to 0, right? So we're talking about when is it 0 and negative. Those are my goals. Okay, so I've got a parabola. Again, it opens up, and it has roots at negative 8 and at positive 1. So I've got some kind of parabola that does this. It comes down and does this. So my question is, when is this parabola less than or equal to 0? So it's equal to 0 at these points, and then it's less than between them. So we're negative and 0, starting at negative 8 and including it, and going to positive 1 and including it. And so that's my answer. Okay? I actually enjoy these because we're actually looking at the function, which is a little bit more interesting. So on this one, Now you could work this a couple ways. You might notice that there's a negative in the front. I generally don't want to deal with having a negative in front of the quadratic, especially if I'm trying to factor, but what I'm going to do is first just get everything on the same side, because I can work with it a whole lot better if I've got the quadratic together. So I'm going to subtract 10x, which is going to put it right in between these two to keep it in standard form. So my question is, when is this parabola greater than or equal to 0? And what I notice is that each of these terms is even, and each of these terms is negative. And I really don't even care if each of them is negative. All I know is that's negative, and I don't want it to be negative. It makes it more complicated to simplify. So I'm going to divide everything by a negative 2 on both sides. And I'm going to remember that when I divide by a negative, I have to flip the inequality. So this becomes a positive x squared. Negative 2 divided by negative 2 is positive 1. Negative 10 divided by negative 2 is a positive 5. And negative 8 divided by negative 2 is a positive 4, less than or equal to, because we divided by a negative, 0. So then I'm looking for factors of 4 that add up to 5, and we've got 1 and 4. So if I think about it in factored form, it's x plus 1 times x plus 4. That equals 0 at x equals negative 1 and negative 4. Always very important that you get the order correct. So I've got a parabola, and it opens up because this is a positive. Now that I'm solving this, I got rid of the negative. And I've got negative 4 and negative 1. So the question is, when are we less than or equal to 0? So we are less than or equal to 0 when we are at 0 and below. So this is another one where it's between the two and including them. So my final answer would be negative 4 to negative 1. Oop, there we go. Okay. Now, on this one, very similar, except for the fact that, well, okay, not similar. Similar in the fact that we're going to factor, but hopefully, maybe, I don't know. But it doesn't have a common factor of 4. It's already positive, so that's good. I'm going to try and go ahead and do bottoms up. 4 times negative 6 is negative 24. So we're looking for the factors of negative 24 that add up to negative 5. So 1 and 24, 2 and 12, 3 and 8 have a difference of 5. Negative 8, that would give me a negative 5 when I add, and a negative 24 when I multiply, so that's promising. X plus 3, x minus 8, less than 0. But I'm going to remember to divide. So divide by 4, divide by 4. So again, remember, if we're talking about when it equals 0, I'm going to say the function equals 0 at x equals the opposite of positive 3/4, which is negative 3/4, and the opposite of negative 2, which is positive 2. So I've got a parabola. Now, unless you make it still have a negative in the front or make it have a negative, we're always looking at a positive parabola, meaning opening up, because I'm always going to make it that way if I can. I know that I'm crossing at negative 3/4 and at positive 2. And the question was, when is it less than 0? So it is less than 0, but not equal, just in between them. So it is in between them, so my final answer is parentheses, negative 3/4, comma 2. And there's my answer. Okay, so last one. On this one, I've got x squared plus 2x minus 6. So if I try to treat it like the others, then I think, okay, the factors of negative 6 that add up to 2. The factors of negative 6 that add up to 2. 1 and 6, 2 and 3. None of which have a difference of 2. Okay? So I could, if you would like to, do the quadratic formula, find the roots, and then plot the parabola. That would be fine. And like I said, that's no different than doing this. We found the roots. We knew it was a positive quadratic. So if you knew the roots and they were whatever they are, you could do it just like we did here. Just draw it and label them. But I want to use the process that we just kind of went over, completing the square. So what I'm going to do is go ahead and add that 6 over. And then I'm going to make this something squared. I know it's x, and I divide the middle term 2 by 1, or sorry, cut it in half, and I get 1. So that's what I put here, plus 1. But then I square that, and 1 squared is 1, so that's what I add to this side, so I add it to that side as well, is less than 7. And then I start solving it like the ones we did on Friday. So I take the square root, and I get x plus 1 is less than the positive square root of 7, but greater than the negative square root of 7. And then I subtract 1. So I've got negative 1 minus the square root of 7 is less than x, which is less than negative 1 plus the square root of 7. So if you'd done the quadratic formula, you would have gotten negative 1 plus and minus the square root of 7. So, okay, square root of 7 on the number line. You've got square root of 4, you got square root of 9, so square root of 7 is somewhere in here. That's 2, that's 3. So no, negative 1 plus 2 point something is positive, and negative 1 minus is negative. So I don't really care where they are. I just know that one's positive, one's negative. Negative 1 minus the square root of 7, and negative 1 plus the square root of 7. And in fact, the relationship to 0 doesn't even matter as long as you know that this one is to the left of that one. So, whatever. The question is, when is it less than 0? Gosh, we've answered that question a lot. So less than 0 is between the two, negative 1 minus the square root of 7 and negative 1 plus the square root of 7. And if they had said greater than or equal to 0, just for kicks and giggles, just make sure. If they said greater than or equal to 0, then it would have been up here and up here. So I would have said negative infinity to negative 1 minus the square root of 7 bracket, and then pick back up at negative 1 plus the square root of 7 and go to infinity. Okay, that is the end of that, and you can use the rest of the time to work on your homework.